Okay, we're going to be looking at angles, the basics of angles, and how they relate to geometry. And first, angles will be used in virtually every chapter in geometry this year, and it's important to know the basics before moving on to our further chapters where angles will be applied. Our topics of discussion today: angle parts, types of angles, relationships between angles, and the angle addition postulate. First, angle parts. An angle is formed by two rays with the same endpoint. So if we look here, we have two rays because they go on forever here. They got these arrows on here, and they have a common endpoint right here. They share an endpoint, and that forms an angle. This common endpoint, it's called the vertex. Let me just erase this here. Now the vertex, if you look at the angle, makes a V. So we say the V right there is for vertex. And each of the sides, the rays themselves, right here, this is a side, and this is a side. Pretty easy. All right, measuring an angle. An angle is measured in degrees, and we say that the more they're separated from each other, the greater the angle will be. To say the measure of an angle, we use a little m to signify measure. So if we look at this here, it says the measure of angle 1 is 22 degrees. Measure of angle 1 is 22 degrees. That's right here. We call this one, if this one were called angle 1. A lot of times you'll see a number in there with no degree sign. That's giving it a name. Okay, and the more spread out those rays are, the greater the angle. One complete rotation going all the way around is 360 degrees, and halfway across is 180. Naming the angle. An angle has three ways to name it, all pretty commonly used, so you need to really be familiar with all of them. First, we could assign a number to an angle. If there's a number in there, like I said, with no degree sign, especially if it doesn't seem to make sense as an angle measurement, it's usually naming the angle. Usually you start with 1, 2, 3, 4. You can't have two with the same name, just like points and lines. So this would be called angle 1. You can name it after its vertex. So this one here could be called angle B. However, you can't use this one if there's more than one angle at this point. This says if there's all, so if I were to draw another ray coming out here, I can no longer say angle B for any angle because it's not specific enough to tell us which angle we're talking about. That could mean this angle right here, or the whole angle. So we have to be more specific and use three letters, which is the last way when we have something like that. Use one letter from each side, like if we had letters here, if this were A, that were B, and this were C, this would be angle ABC or angle CBA. Okay, the vertex always goes in the middle. So this one here could be angle DOG or angle GOD. All right, so we could give four names for this angle right here, and here they are. And we could give four names for this angle right here. Most popular, of course, angle FBI. The numbers in here, I put a little note here. The numbers used are to name the angle. If we're meant to have measure, it would have a degree symbol, and 1 degree for this angle doesn't make that much sense. Even though we don't assume to know the angle measurement by the picture, it makes more sense as a number. All right, types of angles. You're probably all familiar with acute angles, which are less than 90 degrees. and obtuse angles which are greater than 90 degrees, and right angles that are exactly 90 degrees. And when we have a right angle, we draw a little box in this angle to signify that it's a 90-degree angle. There's also straight angles, which are exactly 180 degrees. Okay, they make a straight line together. So this is 180. 180. Sorry, my computer's being a little goofy. Let's just pretend I wrote that perfectly. Great. All right, next. Types of angles. You can see as we grow here, we're still in the acutes. As soon as that angle is perpendicular to it, it makes a right angle. And beyond here, we have obtuse. And if we went all the way straight, it would be a straight angle. So we can do some fill in the blanks here. Now, if you look at the first question here, it says the measure of angle BAC. So for BAC, I'm looking for the measure, which is BAC starts at B, goes through A to C, right here, 60 degrees. Two names for the obtuse angle. Well, we need an angle that's over 90, angle F, or angle GFE. You could also say angle EFJ, or EFG. And then it says, what's equal to 18 degrees? Well, let's see. I'd say angle I. And two names for angle H, angle 5, or JHK. And angle DAC is 80 degrees. Now this is for you to think ahead here. We haven't actually talked about how you would get that, but if you figured out the DAC was 80 degrees all on your own, you probably decided that the parts, these two angles, would add up to the whole, which is our angle addition postulate. So angle relationships, we have congruent angles. All they need is the same measure. Adjacent angles. Adjacent angles are very important. They share a vertex and a side, and they're coplanar, so they look like this. So angle 1 right here, and angle 2 right here are adjacent. And the bisector of an angle, bisect, we split into two parts, and those are equal parts. A bisector splits into two equally sized angles. So if I take this angle and I want to draw a bisector, I need to draw it so that it splits it into two equally sized smaller angles, like this. So I say now this angle and this angle are equal. And that forms, when you draw a bisector, two congruent and adjacent angles, because these two angles are adjacent and congruent. All right, solve. XYZ is 122, and YO is the bisector. What's the measure of OYZ? If you said 61 degrees, you're correct. Number 2, if AD is a bisector of BAC, and the measure of angle BAD is 32, what's DAC? 32 degrees. And what is BAC? 64 degrees. All right. Angle addition postulate says that if we have two adjacent angles, the sum of the two small angles formed will be equal to the larger angle. And what I like to say is the pieces add up to the whole. So if I have two angles, like angle 1 and angle 2 here, I say the measure of angle 1 plus the measure of angle 2 equals the measure of angle CAT. All right. And here's some examples. Measure of angle 1 is 28, angle 2 is 37. What's FOX? You add them together, 65. Angle 2 is 37 and FOX is 77. Then angle 1 must be 40, because 77 plus is equal to 37 plus 40. And if I'm given GOX is 45 and XOF is 80, what must angle 2 be? You probably guessed 35. So to summarize, angles are formed by intersecting rays. They're named in three ways. There's actually four main types, but three main types other than straight angles that we use. And we have special angle relationships that give connections between two angles, like congruent, adjacent, and segment addition, angle of addition postulate. All right, thank you.